Work and energy practice test question 3. Standing near the edge of the roof of a 12-meter high building, you kick a ball with an initial speed of 16 meters per second at an angle of 60 degrees above the horizontal. Neglecting air resistance, use energy considerations to A. Find how high above the height of the building the ball rises, and B. Find the ball's speed just before it hits the ground. So let's write down what's given to us in the problem. We know that the height of the building is 12 meters. And we know that the initial velocity is 16 meters per second. And we know that the angle that the ball's kicked at is 60 degrees. So we aren't given a mass or anything, but that's fine. We can work around that. So let's draw out our roof. And this is 12 meters. And this is our ball up here. It's being kicked that way. This is our angle. And then it goes somewhere, let's say up here. Call that A. And we need to find out how high up that is. So our formula for figuring this out is going to be energy initial equals energy final, which is kinetic energy initial plus potential energy initial equals kinetic energy final plus potential energy final. All right, so our equations are going to be 1/2 times mass times velocity squared plus mass times gravity times height. And that's going to equal 1/2 times mass times velocity squared plus mass times gravity times height. Now I use blue for our initial because that's where the initial energy is, and I used green for what we're trying to find out is A, how high up is that? So let's, well, first we can, since we don't have mass, we need to get rid of mass. And we can divide both sides by mass, and mass will cancel out all the way across. Okay. So now what we have is we have 1/2 times velocity squared plus gravity times height. And we know what our initial velocity is. We know what gravity is. We know that our initial height of 12 meters. And so we should be able to fill out this side of the equation. And then over here we have 1/2 times velocity squared. And do we know our velocity? Well, we kind of do, because we know that when it gets to the highest point, it's no longer going to have horizontal or a vertical velocity. It's only going to have a horizontal. And so we can use that to figure out that part of the equation. And then plus, we know what gravity is, and what we're trying to find out is what is the height over here. So let's plug in some numbers. We have 1/2 times 16 meters per second squared plus 9.81 times 12 meters. And since we have all of our numbers, let's plug them in and see how this turns out. So we have 0.5 times 16 squared. So this will be 128. And then over here we have 9.81 times 12 is 117. All right. And both of these will now be in joules because we're working with energy, and we can add both of these together. And so that gives us an initial energy of 245.72 joules. All right. So now let's work on the other side of this equation. So this side equals 245.72 joules, and this side is going to equal 1/2. So what I was talking about here is when the ball gets up here, its only velocity is going to be in this direction. We aren't going to have any velocity up or down when it's at its highest point. So how do we get that? Well, we can draw a triangle. All right, and the ball starts right here and it's being kicked, and its speed along here is going to be 16 meters per second. And this is our hypotenuse side of the triangle. This will be our adjacent, and this will be the opposite. So we need to find out what this speed is along this side, because we know that this side is 0. And so we know that A equals h times cosine, and we know that the opposite equals h times sine. All right, so we need to use the cosine since we want to find the adjacent. So we can write that in here. So 1/2 times 16 meters per second times the cosine of 60. And then you don't want to forget to square this whole thing. And that'll be the first part here. And then plus gravity which we actually know what gravity is. So we can do 9.81 times height. Okay, so let's solve this right here. So 16 times the cosine of 60 is 8. And then this will be 8 squared. Will be 64. And then we need to multiply that by the 1/2. So that gives us, for this first part, 32. And we have 9.81 times height over here. So 245.72 joules equals 32 plus 9.81. All right, so we need more room here. Okay, so now we need to get this height by itself. And so to do that, first we will start rewriting this equation. So we have our 245.72 joules. And then we're going to subtract 32 from each side, minus 32. And now for the other side of the equation, now all we have is 9.81 times height. So now what we can do is take this 245 minus the 32. This is also joules. And then divide all of this by 9.81. And if we divide both sides by 9.81, that is going to leave us with just the height over here. So let's calculate this out. So 245.72 minus 32. So that gives us 213. And then divided by 9.81. Now that is our height. But that is not our answer because, here I'll show you in a second, 21.78 meters. But the question asked, how high above the height of the building does the ball rise? And what we just measured was from the maximum height all the way to the ground, which includes the 12 meters of the building height, and so we need to subtract that from our answer to get the actual answer. So minus 12. And that gives us a height of 9.78 meters. So this is our answer to part A. Alright, so now we can move on to part B. And the trickiest part of this was just to figure out what its velocity is up here, because once we knew that, we could solve the rest of it. And so just remember that when it gets to the peak, it doesn't have any more vertical velocity because it's hit the top of its peak and it hasn't quite come down yet. Alright, so for part B, we need to find the ball speed just before it hits the ground. Okay, so for this part, what we can do is here, I'm going to just scroll down and we'll redraw this. So we have our building, the ball, it goes up and then it comes down. And we need to find what its speed is at that point. Okay, so it'll be kind of similar to the last one, and all we have to do is this time, instead of getting height, we need to get the velocity. And so what we can do is we know that 1/2 times mass times velocity squared plus mass times gravity times height equals 1/2 times mass times velocity squared plus mass times gravity times height. Alright, now up here we've already solved this part because it's the same as what we had before, and so that was, we know that this side is going to equal 245.72 joules. And we also know that we can divide mass out of this because we still don't have the mass. Alright, so for this side, what we need to figure out is the velocity. Now, for this part of the equation, because this is the kinetic energy and this is the potential energy, we know that the height when it reaches the ground down here is going to be 0. So that cancels out this whole side of the equation. So all we're left with is 1/2 velocity squared. And this is what we need to find out. So we can take the 245 and then we can divide it by 1/2. And if we divide both sides by 1/2, then all we're left with over here is velocity squared. And then, if we just want velocity, which is what we do want, we can take the square root of both sides. And that'll give us velocity all by itself. Alright, so So we can go 245 0.72 divided by 0.5. Alright, now we'll take the square root of that. Which gives us a speed of 22.168 meters per second. And this is our velocity right before it hits the ground. And that is the answer to part B. So the ball's speed just before it hits the ground is 22.168 meters per second. And I realized I forgot to do something that is kind of important. I didn't set up a coordinate system. Or I did, but I didn't really draw it out. So I put the x coordinate down here at the bottom. I put y right along there for the y, and I put the potential energy equals 0 down here at the x. Alright, thank you for watching.